Alright, this video is going to talk about linear equations, and specifically linear equations that have one variable in them. Okay, now, when we use the word linear to describe our equation, what that means, of course, if we're sketching a graph, which we're not doing in this section, we're not drawing pictures of anything, but if we were to sketch a graph of this equation, it would make a straight line. The word linear means line. Okay, we can tell when we're looking at an equation that it's linear when it is degree 1. And degree 1 means x to the first power, or y to the first, or whatever variable we're working with. And again, we're only going to have one variable, so it is an equation that only has x's, or only has y's, or only p's, or only q's. Okay, so again, degree 1 means no x squareds, and no 1 over x's in the equations today. Just x to the first power every time that it shows up. The nice thing about an equation that is linear, that has degree 1, then when we go to solve that equation, we're going to find one solution. Okay, almost all of the time we're going to find one solution. There are situations, 2 other situations that your author covers, and I'll mention here in a little bit, but a linear equation never has exactly 3 solutions or exactly 7 solutions. If we are able to solve for x and find a solution, there's going to be one. Now, to make sure we're on the same page, what it means to be a solution to an equation means if I replace x with that number, it's going to make the equation a true statement. So if the question is posed, is x equals 3 a solution, or we could say the solution to this equation, then what we can do is we can replace the x with the number 3. My tablet likes to randomly stick boxes around things. And it's frustrating, but part of what I deal with. Okay. If I replace x with the number 3, we say, is this statement true or false? And so if we check, it says 6 plus 3 equals 9, which I would say, well, that's a true statement. So yes, we would say 3 is a solution, okay, to this equation. And if 3 is a solution, it is the solution. Again, it is the only solution for this linear equation. There are no other numbers I can replace x with that would make the statement true. So our goal when we're faced with or presented with a linear equation is not going to be for us to guess some numbers for x and figure out whether or not they work. Okay, but we are going to use a systematic approach to solving our equations. Okay, and part of that approach, the real approach that we're going to use is that we have to understand what that symbol means, our equal sign, what it means. Okay. To be equal, 2 things have the same value, or they're worth the same amount. It does not mean they have to look the same. Okay, so if I have 5 dimes in one hand, it's worth the exact same amount as if I have 2 quarters in the other hand. Okay, so again, those 2 amounts look different from each other, but they are worth the same when we walk into the store. So equals means that they have the same value. Now our job and our goal, we'll start with job, when we're trying to solve an equation, and that's whether it's a linear equation or quadratic or any other type, but our one job is that we can't screw up this equal sign. Okay, we can't make the equation tip in one direction or the other. With every step that we do, every idea and thought that we process, the 2 amounts on either side have to still be equal to each other. Okay, now they don't have to look the same. Okay, it doesn't have to be the same amount that we started with. Okay, if somebody says, hey, Ms. Jackson, I found 3 cents on the ground, and they put them in my left hand, okay, now that equation is no longer true. But if someone says, well, I'll help you out, here's 3 more cents, and they put 3 cents in my right hand as well, now those amounts are now the same again. And so that equal sign is still true. Okay, we haven't tipped our equation in one way or the other. Our properties of equality is what they're called, but really the rule is don't tip the scale, don't screw up the equal sign. But as long as you are careful, you can do essentially whatever you want to your equation. Okay, you can add or subtract amounts, you can multiply or divide amounts, but the rule is whatever you do to one side of the equal sign, you have to do exactly the same thing to the other. When we are starting out with our equation, and I'm just going to recopy this guy on the other page. Okay. When we start out wanting to solve for x, okay, our first set of steps is going to involve addition and subtraction. Okay, and only addition and subtraction, and our goal is going to be to get or leave the term or terms with an x in them on one side of the equal sign, and move anything that does not have an x in it to the other side of the equal sign. We have freedom to choose which side of the equals we want to move each of those pieces to. And as long as we do the right operations and the equivalent step to both sides of the equal sign each time, we can do whatever we want to. So since the only place the x shows up in this equation is here in the 2x, I say, well, I would like to unhook this 3. And I can get rid of a positive 3 by subtracting 3. What I do to one side of my equation, I have to do the exact same thing to the other side. And so 3 minus 3 on the left, notice that's gone. It goes away and there's a 0 there or nothing left. So on the left side of my equation, all that remains is a 2x. On the right side, 9 minus 3 is 6. So after I've used addition and subtraction to separate my x's, get them on one side of the equation and my numbers on the other, the last thing we want to do is take care of these coefficients. Since the 2 and the x are hooked together with multiplication, I can undo multiplication by using division. Again, what I do to one side of the equal sign, I have to do the exact same thing to the other. 2 divided by 2 leaves behind a 1, and on the right side, 6 divided by 2 leaves us with 3. 3 is the solution that we had earlier. We know it's a solution because we plugged it in for x and we checked and we made sure that statement was true. So our inverse operations, and there was a video earlier on in another section that talked about additive inverses and multiplicative inverses. Okay, but the opposite of addition is subtraction, and opposite of subtraction is addition, or the inverse, we could say, instead of opposite. Okay, but using one will undo the other. Same with multiplying and dividing. I can undo multiplication with division, like we did here. We can undo division by multiplying both sides. Alright, I'm going to make another video that has more examples that have more steps in them, but this is the gist of what we do with linear equations.